Hello everyone, thank you for coming. Today we are going to present a few preliminary data based on scientific literature about the adoption of open hardware across a couple of industries, particularly healthcare and agriculture. This is academic or scientific research that would ideally complement other research we did last year in a Horizon Action Grant project where we analyzed this very topic through interviews with companies. And we realized that there are a few barriers in the adoption of open hardware that are stronger compared to open source software in a sense. And so we are trying to understand what these kind of barriers where they come from, like from social or industry issues or economic stuff. So as you know better than me, open source software is considered very strategic investment for companies, at least in some contexts, although there is some resistance, unfortunately, still. But the many good things about it are the safety and the free distribution transparency, all things that meet emerging social needs and values. In the context of hardware, the definition of open hardware is exactly the same. It's still about being open in some sense, but with hardware we have many complications regarding where exactly in the process of producing hardwares there will be open components, whether they are in the openness of the process itself or of the product, and then the replicability is not exactly the same as software applicability, but it's something that is embedded in material stuff, and this makes things much more complex. But the general idea is still having something that from which the society and the businesses can leverage to increase their potential, their interoperability and safety. We are going into two specific contexts because open hardware is particularly emerging here as in other cases, but mostly due to the fact that these are contexts that raise several concerns for public investments, for instance. Especially in Trentino, for instance, we have agriculture, but healthcare services are everywhere in the world. Need to be more efficient, let's say. So the research questions we have in mind are these. The first one relates to what are the challenges and the motivations for adopting open hardware technologies. And here the question is trying to understand why the adoption of open hardware is not as widespread as open source software. What are the potential challenges, but also what are the things that we could leverage to increase or improve this situation. And the second question is whether the real-world applications of open hardware are consistent with those things that emerge from the scientific literature. These are relevant questions because academic research not always go into the outputs, but only starts from the assumption that open hardware would be useful and then make a few considerations based on that. So Seckin will present his ongoing PhD research on this, where we have some results that gathering from the literature what's going on, what the literature expects, to be compared at a later stage with what is the actual situation, let's say. I leave you with him.
Hi everyone. And this is kind of academic thing, and it summarizes what we do in the systematic literature review. Basically, Davide presented the two research questions, and one of them is focusing on the academic literature, and the second one is looking at the real world by looking at the GitHub projects and the hardware businesses. And second one is kind of complementary to the first one. Is it the academic literature is parallel with the real world, meaning the GitHub, as you can see here, open hardware repositories collected, and together they are analyzed with some theory from the literature that called diffusions of innovations. Though this thing is our findings, and this is kind of a roadmap to have a successful open source hardware project. And I will briefly go on with them each other, and relative advantage, for example, starting with them, and it's kind of having unique features and quality customizability like open source software, but in this case, relative advantages are competing with the commercial products, commercial hardware. So they should have some kind of unique features and additional things like active community instead of customer service in the commercial ones. And complementary open source software is an important thing. It increases adoption. And some unique features of open source hardware projects we've seen while we're analyzing the GitHub projects. There are some projects like focusing on the niche markets, like in the laboratories, like neuroscience laboratories, biomedicine, and they are not the hardware they are looking for. They are not found in the commercial products. So there are niche part for the open source hardware there. And continue with the compatibility. Basically, it's about the interoperability. You know, we looked at the healthcare industry and agriculture, especially in the healthcare. Interoperability carries crucial importance since you should have a hardware that's interoperable with the existing data systems of hospitals because they're using the 10-year-old software or something like that. And the complexity is basically affecting negatively the adoption of open hardware because the higher the technical complexity, it's hard to adopt, it's obvious, but open source hardware companies or projects can focus on GUIs like graphical user interfaces, and we've seen some projects like FarmBot. It's about agriculture. Their projects are like puzzles. Assembly soldering is easier. Some of them even don't need an assembly line or something like that. You don't have to solder, just Raspberry Pi head, put it on, and put it on your robot and something like that. It should be like buying something from IKEA, basically. And observability and triability is kind of less mentioned in the literature and the GitHub projects, but their importance came later on in our second research questions because the projects having those qualities have much more impact in the open source world, basically, because since they are tangible products, the hardware, the triability is kind of different. You need funding and you need some community events, training sessions, and people should be there in presence. So it needs some funding from the community managers or community admins. Observability, basically, how observable your project. I mean, in the engineering mind, people are creating a project and it's very useful, yeah, but the marketing part is missing in our analysis. So they can handle with tutorials, user manuals, success stories in their detailed documentation part in GitHub or additional community page. So continuing with our findings where we specifically focused on healthcare and agriculture. In the healthcare, basically the more strict regulatory requirements are required to have an hardware in the market. So you need to have CE mark in EU, and you need to have FTA approval in the US, but they are kind of prevented in both continents. So that's the hard part. But in the agriculture, fewer regulatory challenges compared to healthcare because it's not related to patient safety, legal compliance, or anything like that. It's just farms getting an efficient results from the hardware they are producing, and because of that, and healthcare professionals in the hospitals, they are focusing on legal compliance, efficacy, patient safety. But in the agriculture, farmers are more focused on just cost efficiency and compatibility with the system they have. And again, with the private investment of the agriculture is leading to more widespread adoption, but healthcare, since they are focusing on depending on more government funding, it's reducing the adoption rates in that industry. So in this one, we examined the research question too with the GitHub projects, and this graph shows that we get the idea of more stars means more impactful projects in the academic literature. I don't know if it's true or not, because we've seen some projects with less stars and they have more impact, but they are kind of niche, I guess. But in this case, those colors are basically what we presented before, the 5 constructs, and they are subordinates, subsections. And since you can see here, and more colors have more stars. Basically, our constructs and 5 construct map works if you have those things, and you will thrive, basically. But the important thing is here, the observability and triability functions are missing in the less star projects. So basically, it's just they are not bad projects, but they are they lacked some community skills and community pages. They couldn't communicate with the community, basically. But in short, having a great project with unique features is not enough in this case, in open source hardware world especially. You will have tangible products. It's hard to thrive, they are not just basically downloading or compiling anything. You need to have actual products, so you have to market them accordingly. And to conclude, we have this one, but this part is easy to say, hard to implement part, but if you have relative advantages already, you can reduce complexity, technical complexity with GUIs or additional assembled tutorials and training sessions for the potential adopters, and increase compatibility and triability and observability, since they are focused more on the community management. They are in the crucial importance. So, and the side of the factors are really muddy in the open hardware projects, like open source software, because in the academic literature they are focused more on one side is customer, basically, one side is manufacturer. But in this case, it is kind of muddy because of some customers are also manufacturers. So this is kind of academic side of it, but we will focus more on that in the following research of ours. And thank you for your attention. And this is the end of our. Thank you for listening, basically. Yeah.
You can actually ask questions to the presenters if you would like. It seems it was very clear. I might have a question. What are the main obstacles you see in open hardware becoming more relevant and in more projects becoming actual products and getting on the market?
Technical complexity and funding of the projects, and the community management thing is, for the adopter side, it's the technical complexity, basically. But for the project managers or the admins in the project, it's basically the community management. They are focusing more on the product's capability than, basically they lack of the marketing thing. They are in engineering, they think in the engineering mind. It's good, it's beautiful, they should get it. But it's not the case in the real world, I guess.
Which kind of ties up with the presentation that was made of making open source projects become companies. Maybe this is something that is specifically true in open hardware.
But in the open source framework, companies, but not corporate evil companies like in the open source world. Stay in the borders.
Exactly. No, but as we saw before, there are many options, and even probably on open hardware you need a slightly larger scale, because you actually, as you said, you need to manufacture a product, and there are more complexities.
We can say safely that the ecosystem related to open hardware is much more complex. This is how, our finding is, for the moment, the clear finding is that some sort of community management, which also includes increasing the efficiency of communication between the actors, is a key difference maker between those impactful projects and those that are less impactful. So, this is absolutely true.
Perfect.